Yo, let's look at this question that I got from a physics tutorial sheet. So it's saying that a skier with a mass of 62 kilograms is sliding down a snowy slope at a constant velocity. Then they're asking us to find the coefficient of kinetic friction of the skier if the frictional force is known to be 45 newtons. Now, the awesome part about this question is that they're telling us that this skier is moving at constant velocity. And from Newton's first law, we already know that if something is moving at constant velocity, meaning that the sum of all forces acting on it is equal to zero. That means that the forces acting upwards and downwards are equal, and the forces acting left to right are also equal. So, yeah, let's look at it. Okay, let's get into the question. So we have this skater that is sliding down this slope that is at a 25-degree inclination. You see it, right? So now, one thing that we need to know is that whenever someone is inclined, there's, well, a division of this weight, or let's say the weight is broken down into its components. So there is this section that acts on the surface of the inclination. In this case, it could be a ramp. So it's acting vertically or perpendicularly on the surface of this. Then there's also another one that acts parallel to the inclination. Now, this is what you're supposed to do. We can already see that due to the fact that this one is moving in this direction, we can draw another vector that is equal in size and magnitude, and we call this an equal vector in this direction. So this vector is representing this one here. So now we can break this down. Since we already have the angle here, which is the same as the one here, as 25 degrees, we can use some trigonometry to solve for these components. But what the question is asking us to find is the coefficient of kinetic friction, which is equal to the frictional force over the normal force. So what we need to find is the normal force. Now, what's a normal force? So the normal force is the force that a surface exerts on the body that's resting or that's moving on it. So in this case, since this body is applying a force on this ramp in this direction, in this perpendicular direction, this ramp also exerts a force on the skier in the opposite direction, but it's going to be of the same magnitude. So what that means is that this component of the weight is equal to the normal force. Now, in order for us to find this component of the weight, we're going to take this as a theta. So that's just an angle, right? So this is the opposite. That's the hypotenuse, which is the actual weight. And then this side right here is the adjacent. So in order for us to find the adjacent, we're going to use the trigonometric ratio cosine of theta. Cosine of theta is equal to the adjacent. Well, this side is the adjacent. So we're just going to say that's the normal force because, yeah, it is equal to the normal force. And then that's going to be over the weight. So let's just break down the weight. Weight is equal to mass multiplied by gravitational acceleration. Therefore, the normal force is equal to mg cosine of theta. So now we can come and rewrite the formula for finding the coefficient of kinetic friction to be equal to the frictional force over mg cosine of theta. Now for the frictional force, it's already given as 45 over the mass, which is given as 62 kilograms. The acceleration due to gravity can be taken as 9.8, sometimes 9.81, but I'll stick to 9.8. Then we're going to multiply this by the cosine of theta. Cosine of theta, or cosine of 25 degrees. So if you punch all of this into a calculator, you're going to get something like 0.0814 718. Yeah, something like that. Now, if we look at the question carefully, the mass was given as 62 with only two significant figures. But as for the frictional force, it was given as 45.0 with three significant figures. So if we want to know how many significant figures we should leave our final answer, we should just consider the one with the least number of significant figures. So this one had 3, this one had 2. Therefore, the least is 2. So our final answer should only have two significant figures. That's 0.087 there, 1 plus 1, which is 2. And the coefficient of friction is it does not have any units, as it is just a ratio of two forces. So that's how you find the coefficient of friction given such a scenario.